Hey guys, welcome back from break. Before break, we started chapter 8, which was solving quadratic equations. In section 8.1, we solved quadratic equations taking the square root or by factoring, which we've seen before. In this section, we are going to solve quadratic equations by a new method called completing the square. So before we do that, let's just focus and review what we did in section 8.1. So for this example down here, we have only the variable x in one spot and it's isolated inside of something that's being squared. So we can take a square root. So our first step, we have to get rid of our 9. Take the square root. We have to remember plus or minus the square root of 20, square root of 4, square root of 5, so 2 root 5, and then solve this for x. So subtract 1, always put that in the front, and last step, divide by 2. So our answer is -1 plus or minus 2 root 5 all over 2. That is 2 answers, one with the positive and one with the -2 root 5. So, completing the square is a process of us getting our equation to have something that looks like this 2x plus 1 squared. So, we are forcing our equation to have a perfect square, so something squared. So let's work on that process here. Part A, x squared minus 2x. What would we like to be right here so that this is of the form something squared? So the process is you take b, divide it by 2, and you square it. That is what our c is going to be. So -2 divided by 2 is -1, squared is +1. So that is what we are going to be adding there. This is just working on the skill. What is in your parentheses here, our perfect square, is the binomial x minus b divided by 2. So what goes in here is b divided by 2. So -2 divided by 2 was -1. So that would be our binomial x minus 1 squared. If we were to FOIL this out, x squared, -1 makes a -2x. -1 times -1 is a +1. So, reminder here, this is b divided by 2 squared. And what is here is just b divided by 2. All right, part B, x squared plus 3x. How is this one a little more challenging? Well, b is no longer an even number, it's 3. So we're going to go through our process here. So b divided by 2, 3 divided by 2, and squaring that. So 3 divided by 2, them squared, 3 squared is 9, and 2 squared is 4. So that would be what we are adding to make this a perfect square trinomial. The nice thing about putting b divided by 2 right here is this is what x is being added to. So x plus b divided by 2, so 3/2 squared. So make a big note here. This is always b divided by 2. And up here what you are adding is b divided by 2 squared. That will always save you some time. All right, go ahead and pause and try part C, which is a challenge problem. All right. Part C will be as a fraction now. So when we are dividing that fraction by 2, we're really multiplying the denominator by 2. So our b is -1/4. Dividing that by 2 is -1/8, because we're multiplying the 2 to the denominator, and then we're squaring this person here. So -1/8 squared is a +1/64. And that would factor into x. Our b is negative now, so minus our 1/8, that whole thing squared. So that would be your final answer. This would be your binomial squared, your perfect square. And this here is what you were adding. The process of finding what C is to get your expression to be a perfect square trinomial is the process called completing the square. Why do we want to do this? Well, this is a method if we're solving quadratic equations that cannot be factored and don't have that perfect square piece. This is just another way of solving quadratic equations. Hit pause and write down examples 1 and 2, which we're going to work with in a few seconds. All right, example number 1. Make a note here that A has to be equal to 1 in order for us to start the process of completing the square. And also, so check A is 1, so that's good. Then we are going to move C away because we look here, nothing multiplies to get 1 and adds to get -6. So x squared minus 6x, leave a space, equals, I move 1 to the other side, so -1. We are going to do the process of what we just talked about, completing the square, to the left-hand side. So -6 divided by 2 is -3. So whenever I do that, x minus 3, that's what we are going for, because b divided by 2 goes right here. And we're squaring -3, so 9. Since this is an equation, what we do to one hand side, we have to balance it out with the other side of the equation. So I added 9, I have to add 9 to the right hand side here. So that equals 8. And now we just changed an equation that was not factorable and had 2 terms that had variables in it to now having something that has our variable isolated in a perfect square. So go ahead and finish off this problem by solving by taking the square root like we did in section 8.1. All right, so going through those skills we learned in 8.1, we have to take the square root of both sides. We have to remember plus or minus. The square root of 8, 8 is 2 cubed, so we can take out one group of 2, the square root of 4 is 2, and we have 1 left over. And our last step is we need to get rid of this -3, so we add it to the other side and it stays in the front. So this is our final answer. 2 answers there, 3 plus 2 root 2 and 3 minus 2 root 2. And we can leave it written just like that. All right, number 2. What is our first step we need to look at here? A has to be equal to 1. Our next step, looking over at number 1, we moved C to the right-hand side, so we're going to move 6 to the right-hand side. So x squared minus 4x, leave a gap, equals -6. So what will we need here in order for the left-hand side to be a perfect square trinomial? Go ahead and try that out. If you said 4, you are correct. Well, yeah, 2 to one side would do to the other. This was -4 divided by 2, so -2 squared was +4, so x minus 2 squared. On the right-hand side, -6 plus 4, we cannot forget to add our c to both sides, so -2. Taking the square root of both sides, so we have a negative on this side, but we learned from last chapter that we have something special called I, or complex number I, so that would be plus or minus I square root of 2. X minus 2 equals, last step, move 2 to the other side. 2 plus or minus I root 2. That is our final answer. All right, last 2 examples here. If we remember back here, we said A has to be equal to 1. So let's look here. A is not 1, so we have to do something to get it to equal 1. What operation can we do to get rid of the 2 in front of x squared? If you said divide, you are correct. We're going to divide our whole equation by 2. X squared equals 5/2 minus 1/2 x. I need the constant to be by itself, but I need both my x terms to be on the same side. So I'm going to move this guy over. X squared plus 1/2 x, leave a gap, 5/2. Take a few seconds and try to solve for what would make this a perfect square trinomial. like I said on the second slide of this presentation here, b divided by 2, when you have a fraction, you're really taking that and multiplying that 2 to the denominator. So 1/4 is what is going on both sides here. b divided by 2, oh no, I need to square it. So that is b divided by 2 squared, so 1/16. This b divided by 2, 1/4, is what is your second piece of your binomial. Go ahead and combine these two fractions. We need a common denominator. So 2 times 8 is 16, so 5 times 8, so 40. 16ths plus 1/16, so 41/16. Go ahead and finish solving this equation for x. All right, so 41/16. Take the square root of both sides. Have to remember plus or minus. The square root of 41/16 is the square root of 41 over the square root of 16, which is 4. The nice thing about this is the denominator will always be a perfect square in these instances. And then our last step is to move 1/4 over. All right, last example here. We have to get x squared to have a coefficient of 1, so we have to divide everything by 4. Now we need to complete the square. So this divided by 2 squared. So dividing by 2, multiply the denominator by 2. So x minus 3/8 is what our binomial will be. 3/8 squared is 9/64. I always do this step first by dividing that guy by 2, which is multiplying the denominator by 2. And what we do to the left here, we have to do to the right. Go ahead and find a common denominator and add these two fractions together. All right, so to get a common denominator here, 4 times 16 is 64, so 7 times 16 was 112. Combining these two, our fraction is 121 over 64. Solving this, taking the square root of both sides. What is nice about 121 over 64? 121 and 64 are both perfect squares, so this is 11 over 8 plus or minus. So x minus 3/8 equals that. Adding 3/8 to both sides, 3/8 plus or minus 11/8. 11/8 does not have a square root in it, so we can combine 3/8 with 11/8, adding and subtracting, so go ahead and do that. All right, so adding those out, 3/8 plus 11/8 would be 14/8, which is 7/4. And 3/8 minus 11/8 is -8 over 8, so -1. So this quadratic equation, number 4, has these two rational answers. What does that mean about the original equation? That actually means that that original equation could have been factored. We didn't have to go through this whole crazy process. So in the beginning, if I remember correctly, if you get a quadratic equation and you're asked to solve it, step 1, look for a GCF. Step 2, try to factor it. Then, if it has your variable isolated, just solve for that variable. If it already has a perfect square, trinomial, factor, and solve. Here, this one we didn't notice. We went through the whole entire completing the square. Completing the square will always work. However, this is a lot of steps compared to just doing this for factoring out. In a second, I'm going to show you what the factored out form of number 4's equation is. I just need to make some room here. All right, so this was done on purpose here. Example number 4, if we went through the whole completing the square process, this is what we would do. We would get 7/4 and -1. On the right-hand side here, I moved 7 over, and this trinomial 4x squared minus 3x minus 7 is factorable. So our answer here is 7/4 and -1. You will get the same answer. This works really well if it's factorable. Completing the square works when you get stuck and you can't factor or you can't solve using any other methods. All right, go through this as many times as you need to. Pause and go back and look at these examples. Let me know if you guys have any questions. Thanks, guys.